All right, I think we're up and running. Well, good day, everyone. Thank you for joining us. Rob Cedor, I'm a chief architect here at Red Hat for application development, and my partner in crime, Jeremy.
Hi, also an architect at Red Hat.
Right, and Ian.
Yeah, hi guys. I'm a developer advocate now, even though I was a solution architect for 10 years. So I'm still getting used to saying
Cool.
developer advocate instead of solution architect.
Yeah, I don't get to see too many developer advocates. I mean, we see folks all the time like Eric D'Andrea and Daniel O and stuff. Is the same kind of thing.
Yeah, similar. I mean, I because I come from a solution architect background, I'm more sort of want to use the phrase customer friendly. So I don't immediately jump up and down and start screaming about tech, but it's a wonderful role because I get to talk about the stuff that I love without worrying about selling it for a change.
Well, that's cool because today what we're going to talk about is gRPC, which I hope that's why people would join or view this later. And the reason why we're talking about gRPC is because the genesis of this was that we go to a lot of customers and, we get to talk to a lot of people. And as they're doing microservices and getting into that, it becomes a very common question. When should I use REST? When should I use Kafka? When should I use gRPC? When should I use GraphQL? That kind of thing. So the last session we did was on rules to the road for REST. And so we're following this up with gRPC. And while we're not talking about Red Hat specific technology per se, we're going to demonstrate how to do it kind of the hard way and then how to do it with Quarkus, right, which makes life a lot easier for us. So that's pretty much the genesis of that. What we find is that gRPC is becoming more and more popular, especially even in the .NET community, the Java community. It's way beyond just Go any longer. Heck, just the other day, I was trying to figure out how to get it all working properly with Rust. So if you can imagine. So there you go. I don't know if you guys have you seen similar things? Is it the same kind of, I'm not sure what goes on in England. I mean, Jeremy is in England right now. And Ian, I have no idea where you're at. I think you're in England today.
I'm also in England, but I'm in okay. As far west as you can go before ending up in Wales. No, I tend to see it a lot in customers, but it tends to come from customers who don't want to embrace the next generation of REST and stuff like that. So they come from things like an old school C++ background and those kind of days. And they're more into the good old fashioned RPC way of doing things. We do tend to find an issue, and I'd love if you could have a sort of discussion about this during this conversation today, but we do have a kind of, the major issue we normally have is connectivity when you're running it as a container. So if you're running it, for example, in a container running on Kubernetes, you have to get into this whole sort of plethora of node ports and stuff like that in order to be able to do the direct communications. So I'm genuinely interested because I tiny bit of background, so I must say this. I was a diehard Java programmer for a long time. I went through the pain, I guess you both did, of JEE and J2E. I've still got scars from J2EE, to be honest. Whenever anyone says manage beam persistence, I get really upset and cry and go and sit in the corner. So I come from a background of writing old school Java, before all these wonderful annotations and all this Quarkus stuff. So I come from that kind of background, but I'm really interested in seeing how you do the kind of RPC stuff from a Quarkus perspective. But I'm jumping ahead, so.
Yeah, it's very different. I've seen it mostly for performance, people who are interested in performance, the performance gains you get instead of using REST, right? So should we jump into this? Let's look at some of the.
Let's go. So we're going to do a little bit of a mixture here where we have slides and we have a boatload of slides, but we're not going to really go through all the slides per se. That's for your edification after the fact. What we're going to do is mix in the code in there so that we can talk about that. And yes, Ian, I come from a 20-year plus C++ background. And after C++ 11, it became like a different language. It was more Java-like.
Yeah.
But then when I jumped into Java, it was in the days of EE6. So I got the annotation. I didn't do the J2EE thing, so I didn't feel your pain. Wow. And what I'm discovering is that the microprofile stuff that's added into Quarkus and the CDI beans are pretty natural fit for a transition from somebody coming from Java EE or Jakarta EE. So J2EE, I hear a lot of pain about it, and I hear that's why everybody jumped on Spring, but I didn't experience that. So
it's basically why everyone said that Java was slow when it wasn't. And I do a lot of pitches nowadays about please use Quarkus because it makes Java fast, but also it gets rid of those myths that used to be around from the J2EE AE time. But I went through a period of writing. I actually shifted from J2EE to .NET. And that was back when .NET and it was C# actually had annotations before Java. So it was very pleasant to come back to Java and see that annotations were there. But again, if we go on to the Quarkus side, 9 on 70% of the stuff we do with Quarkus is annotation based anyway.
Yeah.
Can you guys see? Oh, can you guys see my screen?
Nope.
No.
Now we can.
Yes.
Sorry again. Okay. So this is my screen. This is the POM file of a traditional. And Rob, I'll hand this over to you. You can just tell me what to click on here. But this is a not Quarkus, just a very typical way of building out gRPC using Java. And I think maybe we'll start with some of the things. You'll notice there's a lot of stuff, a lot of configuration inside of here, right?
So just stay there with the properties for a second. Go back up. So this is a regular POM file for just a plain old Maven project that does gRPC without Quarkus. And there's really no discovery about the gRPC and Protoc version. So on my machine, I have a Mac M1. And if you just do a brew install, you're going to get the latest, right? Unless you do an at a particular version, you're just going to get the latest. And if you do brew install gRPC and you get the latest right at this moment is 1.55.1. And it installs Protobuf for you. And we're going to talk about what Protobuf is. But think of gRPC as the RPC mechanism, right? It's a client server mechanism. It's a communication protocol. Jeremy and I joked about saying this, but for those of us that have been around the block, it's think of it like Corba. If you're from a Microsoft world, that was COM. I think it was DCL or something RPC that ran COM underneath the covers, and the description language at the time was IDL for both Corba and COM. And that's where it stopped. And then you had to implement everything yourself in whatever particular language you were using in those old RPC mechanisms. But when you install gRPC, it comes with a whole bunch of functionality way above and beyond old RPC mechanisms. And in addition to that, the IDL is Protobuf or protocol buffers. And it comes with a compiler for just about every language you can think of. So Python, you can do Kotlin, Scala, Java, Go, Rust, C++, C, and it'll create things for you. If we're doing this with a Maven project, we have to include all these dependencies here in this standard Maven project to get there. And you have to know the particular version that your target is. And if you scroll down, you get to this Xsolstice Maven plugin here. So this Protobuf Maven plugin, what we want to do is actually detect the platform we're on, which can be a problem with particular versions, because if you go back too long, it doesn't support the M1 Mac, and then other versions do support the M1 Mac. So you have to figure out which one's which yourself. And then it detects the operating system and it looks for the Protoc compiler to compile stuff from your protobuffer or your proto file. And then Antler, we all know what that's just going to pull in our generated classes, right? So if you want to show the proto file that we're talking about.
Yeah, we should do. The reason we're compiling all this stuff is we're going to define this. We're going to define our objects inside this proto file, and then it's going to compile everything we need for us, right?
Yep. So what you're seeing here is we gave it a package. The service, greeter service, is actually the thing that is the service. And in Protobuf, we're going to get into this a little bit. We're not going to pass just intrinsic data types. We're going to pass types that are defined by us. So the message, we always have a request and a response. And a good practice is actually to call it request and a response, right? So we know what it is. And you'll also see that there's an enumeration here. So the one is a position. So if you're familiar with the old RPC mechanisms like Corba or COM, you know that those were actually tied to the order that things were put in kind of a virtual stack and C++ in the background underneath the covers. And that dictated the address in memory of where those things were. So we still kind of have that by giving it this enumeration, but because it's hidden from you from a language perspective, you don't have to know about any of that in Java. You just need to know that in our proto file, we're going to say, so if we had hello request and we had added a second element there, it would be number 2, right? And then number 3 and number 4 kind of thing. So all that's doing is telling it what order, and that's going to come in play later when we decide, how we're going to version things and what's a breaking change and what's not a breaking change kind of thing.
One other thing to notice,
very simple.
One of this package, don't confuse this with a Java package because this isn't language dependent. If you want a Java package to work, put your Java package as an option at the top.
Yeah. Think of it. It's not quite like a namespace.
All right. So what do you want me to do here? You want me to compile this?
Just before we go on, just go jump in main really quick, because we don't have that in Quarkus. This is also some boilerplate code that we don't need to put in Quarkus. Now, if we were really doing this in the wild, we'd create a config file and we'd put the port number in there and a bunch of other things. And then we would probably try to attach that to a service in Kubernetes so that we could get the dynamic change, if I moved something or whatever. Here, we're just hard coding it because we're going to run it. And this is the most boilerplate of boilerplate code. We could, I have other code that can make this look really complicated, but at the end of the day, this is really all that's up and running. And then Jeremy's going to compile. He started a service. We used just an arbitrary port number, and I think you're going to use Postman. We're going to go into Postman because Postman has this really cool feature for gRPC. So he already has a collection started. He's going to go to 899. If he imports the proto file, so when you're in Postman, we figure most people are or should be using Postman. When you want to add something new to the collection, instead of saying an HTTP REST endpoint, you can actually choose gRPC now when you do new. And then you can point it to the Protobuf file, the .proto file, and it'll get the definitions for us. And there you go.
And
that's pretty much all there is to it.
Our actual work is done in this hello service, right?
Yep.
What of us not happy about something
now? You'll notice it's a little unnatural here because we have a void for the function, and the first element is the request and the second element is the response, right? We know Java does this by val by ref thing. So, for C++ programmers, that's not a pointer. in .NET, it would be, by ref. I think you'd have to put the by ref keyword in there or something like that. But anyway, the point here is that we have a stream object for the response. We're going to build the message out of our request, and then we're going to say when it's completed, you're done, and then we exit. The reason I say it's unnatural is because we have that void in front of it, and then your request and response are in the function call. So when we get to Quarkus, it's going to look a little more natural because it's going to look like a regular function definition.
we'll also see a couple other nice things. So now, I just recompiled. I changed that to hello, comma, and add an exclamation point. We're calling it saying hello, dude, because we're using basic Java. I have to stop and recompile, and then.
So yeah, that's a thing, Jeremy. So you got to stop and recompile, and in Quarkus we got the live coding thing going on. So I think we're going to talk a little bit about that too. So that's it. That's a basic gRPC with Maven and Java. I don't know, Ian. Looks pretty simple, right?
Yeah, absolutely.
Yeah. And we can make it way more complicated. But Quarkus, actually takes and simplifies that whole thing. So I don't know if you want to wait, Jeremy, or we can jump into that now.
Into that right now. Well, you want to jump into that right now, or you want to do some slides? We want to look at.
Yeah, let's look. Yeah, we got all these slides, so why don't we look at some of these slides? So.
All right, let me share my screen again. And we'll start here. Okay. That's us. We've already introduced ourselves.
Yeah. People aren't interested in some of this.
All right.
Okay, cool. So last time we talked about REST, and REST is really a resource-based mechanism. And we're going to talk a little more later about the differences between REST and gRPC. There's, pros and cons to each. I would say for those folks that are probably coming from an environment where they had a monolith and they were trying to decompose it, maybe into hexagonal architecture or something, but not going all the way into microservices. We've had talks about that and what those decomposition patterns are and stuff like that. But gRPC represents a great way for basically a high performance communication between your stuff that's more coupled, right? If we take a look at the things that are using gRPC today, well, if you're using containers at all, it uses gRPC under the covers. If you're using Kubernetes, it uses gRPC. So that's what all the communication is in. It's very easy to version it. It's very easy to control what you're doing and what you're running with gRPC, and it gives a bunch of performance enhancements that we're going to talk about in a little bit. GraphQL is basically a query language kind of mechanism that we would stick onto HTTP. WebSockets, webhooks, we all know about that. The thing at the bottom, we try to avoid SOAP, but there's still a lot of people out there using SOAP. The reason why I'm even including this on the diagram is because people that were using SOAP were basically trying to replicate an RPC mechanism across HTTP. And they got into all this WSDL definition. And in order to do that, you had to have XML-based definitions for all your data and everything else. And you got into this morass of, what's the difference between an exception and an error? And how do I handle that? And we redefined it over and over and over again. And it only did HTTP, up to 1.1, right? The same with REST today. It's HTTP 1.1. And we're going to get into gRPC's mechanism for using HTTP 2. And we might even touch on later, maybe briefly touch on what's coming down the pike, which is the new standard for HTTP 3. So, but right now, HTTP 2 is going to give us a bunch of advantages we're going to talk about in a little bit. I don't know if you guys have anything to add. I hated SOAP. I hated it with all the passion that I could. And I was in Barcelona when Don Box from Microsoft sat in a bath, was wheeled out on stage and sat in a bathtub and gave the whole SOAP talk back in the early 2000s. That was the first real big SOAP talk. I don't know if you guys ever Googled for that. Look up Don Box and SOAP speech Barcelona. He talked about SOAP and everybody loved it because it was a web-based kind of RPC-ish mechanism, right? That's what everybody wanted, right? So, and it never fulfilled its promise. It just created super complicated life for us. But I could go on for the next 45 minutes, I guess, about that, but how much I disliked it. But
I still have SOAP. I still have SOAP UI on my desktop.
Seriously? Oh, wow.
Sorry,
But it does rest now, doesn't it?
Yeah, sorry about that.
It's one of my critical tools.
Is it really?
Yeah.
Do you have? I mean, are there that many people still using SOAP? I guess there's probably a lot of legacy code out there, right?
Yeah, it's more to do with the legacy Windows estates. So there's a huge amount of legacy .NET, pre.NET 3 estates out there, which are all based around SOAP.
I didn't know .NET was a SOAP. Could you do SOAP stuff? I never really did a lot of .NET, but
yeah, before .NET became .NET Core, it was basically run on the website. So it was IIS and the SOAP interfaces and all those kind of things. But there are a surprisingly large amount of systems out there that still use SOAP.
Really? Okay. All right. So hopefully everybody feels as objectionable about it as I do. But
well, I am feeling like the Luddite now.
Really?
We already did most of this stuff, right? We installed, or we didn't show you brew install, but yeah, you have to install gRPC, right?
Yeah, you got to install gRPC. It'll have it's required at runtime, but the Protobuf compiler isn't required on a target machine.
Sorry, a very dumb question from the Luddite. What does brew actually install then? So what makes gRPC on the machine? Is it a set of APIs?
It's just libraries. Just think of it as libs. Yeah. Okay. If you're on a Linux machine, it's going to install some libs. They do have to be. There is some compatibility required. I'm sorry. Yeah.
Does it bolt you to a specific version? Is that what you mentioned earlier? That once you do the brew,
I can have. What I prefer to do is put it in, do the development in containers, or, in the old days we'd use virtual machines, but now, containers, and then just have the container versions. What I've played with is, what's more important probably is having the same version of the proto buffers, right? Yeah. Because that's how your definition is going to generate the code for you. And making sure that you're both using compatible proto buffers for the client and server.
Yeah.
For the generated code.
All right, so we mentioned that Quarkus is easier, right? So it knocks a couple of these steps out, but it's fairly similar, right? You'll need to install, if you want to use the Quarkus has a CLI and a project generator. If you want to use the CLI, you need to have that installed. If not, you just use the generator. You still define your service, right? That's going to go on with any language you use or toolkit. And then Quarkus makes the compilation of code generation easier. So you can do it in the same step that you just build everything. And then you create your apps. So should we show off Quarkus next?
Yeah, so before we start that, just jump over quick to the code.quarkus website. Oh, yeah. Cool. So if you go here, what Jeremy and I did to start this project off is we just chose the top one and added the gRPC code. So, right. But if you scroll down, there's actually a gRPC project that'll get you started. Probably just search for gRPC. There you go.
Well, yeah.
Yep. So, oh, and the camel one. Don't get me started about camel. I'm in love with that. Yeah. So, yeah, I should send Klaus Ibsen a bottle of something every year. So he does all the work, fabulous work on camel. But yeah, so you can choose a gRPC project. I would say the only caveat here is we're going to have to add some stuff to your Maven to pick up the generated files, but we're going to do that anyway. So if we jump into the code.
Let's go here. Let's create the project from scratch.
Yeah. Oh, you're going to generate it from scratch? Sure. Okay.
Yeah. Here. Go back up a directory. Got some other stuff in here. I'll say Quarkus. I'll use the CLI for this. Create app. We'll say come Red Hat dev corner, and we'll say what do we call this? gRPC dev corner.
And I assume that this is Quarkus 3.
Yeah.
Yeah.
Oh, I don't know. Are you using Quarkus 3?
I am using Quarkus 3.
Okay, cool.
Because I switched to using Quarkus 3 last week, and all my JavaX stuff no longer compiles.
Oh, really?
It's because it's moved to Jakarta.
Right.
So.
Right. Oh, the namespace changed. Right.
Yeah, all the libraries changed.
Yeah.
And well, actually, I've already got IntelliJ running, so let's just go ahead and pull IntelliJ. Close out the project I was showing, and we'll just pull this in as a module, right? Module use existing sources. We're in gRPC, and we just did gRPC dev corner, right? Pull that in. It's Maven project. Give us a second.
Does your IntelliJ turn your Macintosh into a hairdryer like it does mine?
No.
Really?
Yeah, I've got an Intel, not an M1, so it really thrashes it. So the
No,
back
it. I'm going to tell you. This isn't an Apple commercial, but I have a beautiful Dell XPS laptop here with 64 gigs of RAM.
Yeah.
You know, an i9, blah blah blah, and it's wonderful. And I run Linux on it. And on my Mac, you know, I have 3 IDEs open right. I have IntelliJ open, GoLand, and Sea Lion, all open right now on my desktop. Plus a bunch of other crazy stuff open. And the battery will last hours and hours and hours on this thing. And if I had the same thing open on the Dell, it's hour and a half tops maybe. And that's running Linux, which is using way less resources for some reason. But the fan will kick on, you know, not to smash on Dell. I love the XPS, but that Mac is amazing with its resource utilization. So,
yeah. So
all
first
right.
thing, notice, yeah, here we've got a lot less in here, right? This looks like any kind of Quarkus project you're going to generate, right? So
Yep.
Quarkus compiler, all the other stuff is abstracted away. I don't have gRPC installed on my machine, by the way. And then we've got a couple of things in here.
Oh, you didn't install it on your machine because you're pulling it, right? Yeah.
Oh, actually, you know what I need? I forgot to install Quarkus. Quarkus, and I'll say Quarkus RPC. I forgot. I grabbed Resties React from the command line. I forgot to grab it. Grab Quarkus. So let me just tell get IntelliJ to recognize that I have now changed the plugins. All right, and you know what? Let's just instead of just starting that Protobuf from scratch, what we'll do in Quarkus, we'll create a folder here, new directory, and we'll call it Proto. And let me just copy the one that we were using from the non-Quarkus. I'll just use the exact same one, right?
Yep.
That makes sense. So Proto, I'll just copy and paste that in here. So but I will change this to.
That's code reuse, right, Ian?
I wouldn't know.
All right, so in this case, we have, let me get out of presentation mode here. So appearance, exit presentation mode. So we've got the same file. I changed the name of the package, right? So we're going to match what the project we're in. And I'm right here in dev corner. I'm going to run Quarkus build here. We'll run this out and should notice I should have skipped tests. Let's see. We were compiling some files. Let's see if we got all our files in here. So inside of our target folder, we have generated sources and gRPC. Let's take a look here. So Quarkus generated all of these for us right here, right? So we've got a couple of different things, greeter gRPC and a greeter. If you look at our greeter class, this is an interface, right? And it has one method in it, right? So it's one method here, and the method is say hello, which has been generated from our proto file. It's got our, it gives us generated class is always a little bit ugly, right? Generated code, but it gives us our, our reply and our response, right? So we can see that. Oops.
And what Quarkus did was it discovered what platform he was on. So he's on a Mac OS, Arch 64, right?
Yep.
I think, right? You're on an M1.
Yeah, on an M1. So
yeah,
on an M1, it discovered all this.
And it discovered all that, pulled it all. I didn't have to tell it anything, right? And and then generated the code with the right Protoc compiler that was compatible.
So the interesting thing to me is it's actually using the Mutiny stuff, so it's using the asynchronous stuff.
Yeah, it's using it. Yep, it's using the reactive stuff. Yep.
We don't have to at all. So, but introduces greeter. Well, my palm should have picked up the new code, but let's just reload the project just to make sure.
Is there any reason why it defaults to using Mutiny? Is that
it doesn't. So both are generated in here. So if we want to look at gRPC, we've got it right here.
Yeah.
You have both options, right? So Quarkus it provides you with reactive API, but doesn't force you into reactive API. We've already seen the traditional one. So the greet is if we were to use the imperative API, it's going to look exactly like the non-Quarkus one we just generated. So I was just going to skip that. But we could do it exactly that way if we wanted to. And so I'm going to implement methods. We need our say hello method here, right? And so Mutiny, if you have not used Mutiny before, Mutiny has the concepts of unis and multis. And this is a reactive framework. A uni is one thing and a multi is multiple things. And so we need to inject we're creating our gRPC service. So what we want to say is return uni create from item new. Sorry, not new.
That's a great question, Ian, because one of the things we're going to do is the streaming stuff. And it's going to be, if I was doing that, with just writing the Java code where I said I could make it way more complicated, that's going to look way more complicated than what you're going to see when you're using the reactive code that Mutiny provides.
Yeah.
Yep.
Unless you don't like reading the reactive code.
Right. Which reactive code can sometimes be a little bit, complicated, right? But essentially what we're doing here is we are calling, we're going to create a uni, meaning we're creating a singular response. We're creating it from an item. The item that we're creating it from is going to be a hello reply. And that was one of the messages, right? Or the objects that we defined inside of our Protobuf file. That's been built out for us by Quarkus, by our compiler. Our hello reply is right here. So we can still see, if we want to see like all of our methods, which is the class structure thing.
A tiny question for me on that one as well. The Protobuf stuff, is that also compiled by the Maven build as well?
Yeah. I just used the Quarkus builder. So under the covers, Quarkus took care of it for me. Maven will take care of it as well. So now
it's a two-step process. First, you got to the Protoc. It's going to pull in the Protoc compiler for Protobuf.
Yeah. Discover
the language that you're using right through, because Maven did it. It's going to pull down the right version of it for your platform that you're on. And then when you compile, it's going to compile it in. Right. And so it's, think of it as the code generation part and then the compiling it into your code part. Cool. So it's almost like static linking into your code, right?
Yeah. Is it a separate build step in the Maven, or is it just automatically done? So
well, for us in the straight up Maven, generic Maven code, it would be a separate step that you're going to call. In the Quarkus, that's all hidden from you behind the scenes. Cool. I'm sure that it's actually kind of controlling the running of that behind the scenes. But for you, it's kind of transparent. The only thing that Jeremy had to do was actually pull in that new dependency.
And so
versus having to know all the other stuff that I showed you. And the more functionality you want to include in a normal Maven project, the more stuff I would have to include in that POM file and know what it is and where it goes and what version numbers. With Quarkus, it's going to dynamically find that for you.
Yeah, that's utterly brilliant, because I don't want to spend my life writing Maven POM files.
Yeah, it's I have the same feeling about YAML, by the way. But yeah, I don't want to have to manage all that all the time, and I don't want to have to keep track of deploying a particular version to the my target platform either.
Yep. So we're here. So now we're saying hello. Let's make it sound more emphatic too, right? So plus, right? And so now we've got our API. And if you guys were watching, what I did is I just created a new API. I chose gRPC, and then in your service definition, you can just import the API, right?
Yeah, but the cool thing that Jeremy did was that we couldn't do the other way around. Was he did that while the code was already running.
Yep. And then another kind of nice trick that I like. So there's different, and we'll talk about this in a second, but inside of Protobuf, right, we've got a couple of different, or inside gRPC, there's a couple of different ways that we can send these messages. So we have here, we're sending one request and getting one response. But what we can also do things like where we say hello multiple times, and we can say a hello request, and we can say returns stream hello reply.
So Ian, I don't know if you noticed, but Jeremy types like about 150 words a minute if you include the backspaces.
So yeah.
Sorry, Jeremy, I just needed to.
So we've got say hello multiple times, right? I've got a new method in my interface, right? So let's come back to our, what do we call it? We call it mutiny greeter. So now I've got an error in my code, right? And so what does it want? What is it doing? It wants to implement the method, because running Quarkus in dev mode, it's watching everything, including the Protobuf files, right? So it knows that I've now, it's recompiled because it says Protobuf files changed. It's gone ahead and recompiled, regenerated everything. I haven't had to stop or run compile or anything again, right? It's really nice. The dev mode extends to gRPC. So now I've got
that was literally where I was trying to get to from the question perspective, because it's two different steps, and you're not actually doing a compilation of Java. You're actually doing the Proto C in advance. So it's very cool that Quarkus Dev actually handles that as well.
So we've got, you know what, I'm going to cheat on this and copy and paste my method here. So, because it gets a little bit. Let's say hello.
While he's doing that, and for those Gradle aficionados out there who are like, it's in Maven. If you're back on that website where we generated the original project, there's a Gradle option there.
So yeah, you can use Gradle. So what I'm going to do here is I'm just creating a list of replies that I can then, I thought I'd add some like nice little things to say in here. So say a list of replies, I'm going to stream through that. And this is not particularly Mutiny. This is just Java streams, right? And then I'm going to map that. I'm going to create a new message based on the request get name plus one of these little responses. And then I return a new hello reply. And then I collect all of those as a list. So then I'm going to call my multi, and this is Mutiny. I call multi, and I'm creating it from an iterable, which is replies. So what that means is I'm going to have one request coming in, and I'm going to send out multiple replies, right? So let's come back and look over here, and we don't have to do anything new either. I should have this. Actually, you know what? We can refresh this. I think this will pull in both methods. Did it not? I thought it would pull that in. So anyway, we'll just import our proto file again. Import it as an API. We got localhost 9000 there, and we can now we have both of our methods here. So we'll say hello multiple times. So what we'll do. So I'll say hello London. Actually, that won't make any sense because our greetings won't be making you feel better. So say hello to Oof. And now what happens is we have multiple replies come back, right? So we can see, I'll zoom in a little bit so you can see. So we have one request sent, and then 3 replies returned. So Oof, have a wonderful day. Oof, your wit and wisdom are apparent. And Oof, your skin tone is fabulous. You are a master of hydration. So we get all 3 back, right? And we can do this, different ways. So there's a couple of different things we can do with Protobuf too. I think maybe we'll talk a little bit more behind the scenes stuff and come back to that. But there's 2 other things we can do. We can do bidirectional streaming, and we can also send a stream of multiple requests that are then collected and batched back as a response. And we'll show those in a couple of minutes.
There's another question from me on this, if you don't mind. When I'm using Quarkus Dev mode, because I like REST. So I missed the last one when you guys talked about REST, but I used Quarkus Dev to do some REST test. And if I change the code, it doesn't actually do a recompilation of the code until the REST request is requested. So if I do, for example, a get and put it on a subdirectory and then put a return of a value, when I save that code, there's no actual build of the code until I request it, at which point Quarkus then does a very quick rebuild of the code and sends the new version to me. Now, with that, I noticed that when you do the change to the buffer itself, the build was done instantaneously. So the build was done on the change of the code. Was that something I was doing wrong, or does Quarkus Dev have a different default way of doing a build based on the actual technology it's actually doing at the back end? Does that make sense?
Yeah. So
That's a great question.
It might be. Yeah, we can see in a minute. We can try that out in a second. So actually, if you want, so that was implementing. Maybe since we're doing that, we'll just go ahead and implement a consumer, right? So we're using Postman as a consumer right now, right? But we can also create a consumer inside of Quarkus, right? So let's say we have our Mutiny greeter. Let's say Java class Mutiny consumer API, right? And we'll say get add path, and what do we call this? Hello gRPC. Do an add get. That was a public.
Look at that fantastic import with Jakarta, not JavaX.
Yeah. Why is this not getting picked up? Come on.
So I'm only slightly cross because I've broken every IDE on my machine. So I'm currently using NetBeans for those who want to really feel old.
NetBeans.
Yeah.
You're hardcore.
It's the only one that actually works at the moment.
That's like C++ programmers who use Emacs, right? That's the hardcore people. I find that Visual Studio Code is advocated a lot, but mostly by people who come from like a JavaScript background. I use it just as a replacement for Atom, right? Yeah. Because I like to have an editor also kind of on the side. We create the plugins for it at Red Hat and all that, but I still wind up going to the JetBrains family of tools for just about everything. It's, I don't know, feels comfortable in JetBrains, but tools, but and they're all the same. So if I'm doing Golang code and Goland, it's basically the same IDE as IntelliJ, right? So
it's a bit it's a bit like a religious war because
I don't like to get in that kind of war about which one's which. I just know which one I personally feel more comfortable with. And
I come from too many years of pain with Eclipse.
Eclipse. Well, that one's not really religious. I can definitively say I never liked Eclipse, but
so we have here hello gRPC, right? We are I have injected my gRPC service greeter. Quarkus knows you don't have to tell it to inject it.
Yeah.
And I've got a path called name, and I'm going to return a single thing, a string, and I'm going to get it from this path param, right? So I'm calling my method say hello, and I'm just creating a hello request on the fly to pass in, right? And this is the method we have hello request. This is how it's generated, right? So I'm going to pass in my hello request, and when I get it back, and this is when IntelliJ tells me what I'm getting back. I'm getting back a hello reply. I'm going to transform that hello reply because I don't want the whole thing. I want the hello reply get message, and that's the syntax. And now I return that. That's going to come back as a string. So let's come up here and see what that's going to look like. I need new, and we'll use HTTP this time. Localhost 8080, and we'll say hello gRPC, right? Hello gRPC, and we'll say, right, and so there we go. We have hello Rob. Now you were saying you weren't sure it compiled, so let's just do something like this. Let's say logger, add a logger here, and we'll just say
so literally I was doing a live demo to a customer, and it occurred to me that it was only doing a compilation when I actually requested, when it got the request for the changed method.
I need to. I'm gonna have to set my logging parameters if I do this, don't I? Yep. Let's see in notes.
Again, this is purely out of interest.
No, it's a great question.
That's a good question. We'll find out here. Hang on a second.
Because the theory behind it is that it only needs to recompile it when it's called.
Right.
So let's see if we got a log. Well, it said live reload time. We didn't get our log there. Let's try this. Let's change our greeter. Let's add another list in here. Let's say insightful comments about software. There we go. There's another. Oh, that's not what we called it, was it? So let's say hello. I'm not touching the code for the REST API, right?
Yeah.
Yeah, but yeah, it's still it compiled. It caught it. So maybe it's an older version or something. Anyway, so what we've got here, we have a consumer API. This is what it looks like to consume these. Well, we can go ahead and consume one too, I guess, if we want. Multiple one. What do we say hello a few times? We could say get. We could say path. Let's say multiple times. This would be a public multi-string, right? And we could actually return the hello reply. Say hello times. This path param string name. Well, multiple times, then I'll need to put name there so we get that. This time we will return, let's say greeter, say hello multiple times, right? And so we're going to send in one hello request, right? New hello, or not new hello request, we could go over hello request, new builder, name, build. Right? And then we want to do, when we get that back, I think I might cheat again here because we're going pretty fast today. So what I'm going to do is map the reply. Okay, so then I'm going to say, when I get my reply, I'm going to say app reply get message. Well, what's it mad about? It's mad about unexpected token. Okay, so what this is going to do is I'm going to say hello multiple times. I'm going to send this request out. I set the name on it, create the request message that gRPC is expecting. When I get it back, I'm just going to call. I'm going to get back a hello response, a hello reply, and each time I'm going to say get message, and I'm going to stream them back out to the front end. So let's take a look over here. We need to say hello multiple times. We've got say hello multiple times. And we've now got all four of ours. And so let's do a get request, localhost, 8080, hello gRPC, multiple times. There we go. Rob, you have insightful comments about software. Rob, have a wonderful day. Rob, your wit and wisdom are apparent. Rob, your skin tone is fabulous. You are a master of hydration.
Wow.
So,
Okay.
we now have our guests. We have our get request as well, right? So this is basically this is how you build a client, right?
So this is the client. I mean, Jeremy just built like almost a BFF or something like that pattern where, I could now do an abstraction, but behind the scenes, I have a client and server or, producer consumer for the gRPC mechanism. So, some things, we're probably not going to demonstrate here is like, something that's blocking versus non-blocking, that kind of discussion. But I'm gonna cut and paste just some, wit and wisdom here into the into the chat. Hopefully, if I can
And we
find
are
it.
we've gone on a lot of tangents. So in case people have to leave for 2, let's see if we can. Let's jump. We've covered what gRPC is, I think, pretty well.
Well, here, just go real quick to the look in your chat, and then on the for the session here, and just click on that GitHub thing. Oh, here, I'll send it to the other. I guess I'll send it to your other chat.
What? Just tell me what it is.
Oh, it's too long. It's just, what does gRPC stand for? Most people think it means Google, and it doesn't. So there's a link I will share with a README, and every version of gRPC means something different.
So it currently stands grounded.
Right. There you go.
Does that mean like you're well-grounded person?
I guess there's an infinitesimal amount of G's, so we can have an infinite number of versions.
Yeah, but
go ahead back. It's in the slide deck, but we'll put it out there when people are get that. Let's zoom through a couple of these things because you know what? Let's here just
here
put the slides up there for a minute. We have a client-server mechanism. This is basically how it works. It's just like every other RPC mechanism. Google's gRPC isn't really different in that perspective. Keep going. Yep. From the perspective of what are the core concepts? So HTTP2 is a core concept. It's something that came out in 2015. It's supported by basically every browser, and it's got a bunch of capabilities that one of which is this binary framing layer, and basically says HTTP2 request response can be divided into small messages and framed in a binary format, which makes the message transmission much more efficient than HTTP 1.1. So the binary framing allows request response multiplexing also possible without blocking network resources. So this is really important because this is what gRPC is based on and why it's pretty performant. Go on to the next slide. Another aspect of that is that the previous aspect allows us to do some other things too, like header compression. So everything in HTTP2 includes, including the headers, is encoded before sending. So this significantly improves, overall performance. And it uses something called the HPACK, capital HPACK compression method. And it only shares the values that are different from a previous HTTP header packet. So in this example, if I have request 1 and request 2, when I change something, it's only going to pass the thing that changed. Right. So go on to, we're going to zoom through these pretty quick. This allows me to do, protocol, there was another concept, from HTTP2, like streaming and flow control and processing. Those are all things that allow synchronous and asynchronous processing, which allows me with protocol buffers to do a bunch of things that we just demonstrated, like the streaming capability or the multi capability. So protocol buffers, think of it as, the IDL that we talked about earlier. It's a way for us to standardize serialization and deserialization. It's very different from when I do REST because there's no standard. I can, in gRPC, I need to do my design up front for what my API is. Now we can say your standard within your company might be to use OpenAPI and Swagger or whatever, but there's no actual RESTful standard for that. There's the RESTful design, but there's nothing enforcing that other than your own internal enforcement of it. And that could be different everywhere you go. This provides a standardized way to do it, which is what makes it, pretty popular. And the Prodoc is basically, Proto-C is basically the Protobuf compiler that generates everything that we've been talking about. And it really creates this efficient in-memory schema for serialization and deserialization in a binary format, which makes it much more efficient. Keep going to the next one. Some additional, some additional points here. Your streaming, channels, metadata, load balancing, call canceling. All of these things are additions that it brings to the table. So when I say performance, you're really talking about speeds. Speeds may vary, of course, but generally we can expect something like 10 times faster than just a API, RESTful JSON communication. From a streaming perspective, Jeremy already started talking about unary streaming and bi-directional streaming, but you can do client server streaming, server to client streaming. There's a bunch of different capabilities there. Metadata and interoperability. Think about it as, we talked about all the tooling. So the same mechanism can be used with JavaScript, Java, Ruby, C#, Dart, Objective-C, C++, C, Go, whatever. Security, HTTP2 uses TLS. And usability, we kind of talked about that. So let's talk about real quick comparison with REST.
Oh, sorry. Yeah.
Yep. I think keep going to the next one. Yep, there you go. So this is where we talked about REST the last time. I just talked briefly about it. There's really no standardization on what REST is, unless even when you get into RESTful things, where we talk about using the media type for versioning and what that enables us to do, etc. gRPC has, very well understood standardization. The RPC mechanism, it is client server based, but it's very efficient and fast. So if you're doing those things where you're modernizing an app by componentizing things and breaking down your monolith or whatever, or you're doing something from scratch, a lot of times people are using REST calls instead of maybe Kafka to do decoupling. They're doing REST anyway within their, service to service, and they think that that's the way to go. But it's not as performant, right? So what I would say is, gRPC is going to be much more performant internally and use REST from the outside in, because your external clients are going to probably want a RESTful endpoint. That's pretty standard to present to somebody. But internally, you want as fast a performance as possible, because that request latency is really the accumulation of all the calls after you get into your service calls, right? So I want that to be as fast a communication as possible. From a design perspective, this is what's most important to me personally is, the API design, we can say, we can, again, open API Swagger, we can do that and generate some stuff from it. But really, REST is a code first kind of design, and gRPC is a design first kind of design. And I enjoy that a lot more. JSON, here's where some people get start to diverge here. So JSON's a human readable format, and Protobuf is not, right? It's binary format.
But you can't use JSON with you can't use JSON.
You could use JSON. That's true, but you're still going to serialize it as a string, right? And you're going to put it in a binary format. The deal there is people like that human readability because they can see it. I'm more interested in the performance of it, right? So it's really a trade-off on what you want to do. And architecture is what? About the least worst thing that you could choose. So, I want the performance, so I prefer the gRPC mechanism. I don't know. What do you guys think about these?
I mean, my take is it is depending. I like that. I mean, I love that. I think it's Neil Ford that came up with that quote, right? The architecture is not the least worst decision. So right. If you want performance, which is most of our customers that I work with who use gRPC have made that decision because they are squeezing performance out of their app. Right. So that definitely seems to me to be the primary use case. Can we run through it? We don't have much time left, but I think
we can run through these really quick.
So it's
what I would say is, if you don't take anything else away from this, There's a really good linter that works with IntelliJ. I think there's a plugin also for VS Code. Why do I say that? Is because the style guide, I would say go to the style guide. Go to the style guide for everything and you can't go wrong. So even if you don't take anything else away from this conversation, but you're interested in gRPC, definitely go to the style guide.
Well documented too. Both protocol buffers and gRPC are well documented.
Yes, super well documented. So go to the next one. Definitely separate your request and your response messages. Right. So, always, don't do the first thing where you're trying to reuse order, for instance, and create order. What I would say is, create the order request and the order response. But just make sure they're separate, because if you start to commingle them and then you need to change the response for some reason, you're now stuck with, the request and response being the same, like in the create order example. Just separate them out. Keep going.
Single responsibility.
Enums are a problem in any language. And the reason why they're a problem is because they're a problem when you cross languages. So code generators, like for C# might, remove the prefixes to keep the code looking quote unquote clean. You might have duplications across enums where that causes trouble. And other languages like C and C++ don't see enums the way that other, additional languages do, right? So in addition to that, use well-known types. So there's a couple different kinds of things when I say types. So when you installed or use Protobuffers, it will come with, on your machine, if you install it on your machine or whatever, it'll come with a path to a bunch of kind of intrinsic types, if you will, that are for Protobuf. So don't recreate the wheel. So a timestamp is a timestamp. If you have a special meaning of timestamp, then create your own, but try to use the ones that are there. Empty is another one, any is another one. In addition to that, there are some Protobuffer definitions that you should probably examine using, but then you'd have to include them into your proto, such as money. Money's one. That's an interesting definition, because we all know that if I use difference between euros and pounds and dollars, and maybe if I'm in India, they put commas after certain things. Versioning, there's a bunch of rules to the road to versioning. So when we talk about versioning in particular, we're looking for backward compatibility. So basically, same as all old gRPC IDL mechanisms. Adding things is okay. Adding things optionally is okay. And breaking changes could be in older languages when you delete something or remove something. Here with Protobuffers, a lot of work went into making sure that things didn't break, right? So I can actually delete a field and not break my interface here. So again, the style guide and looking at things. So removing fields, might be a breaking change, but deleting under certain circumstances might not be. So next, optional fields. Optional fields is interesting in the sense that we might want to check things for nullability. And there's this whole thing with that link there, so we can actually track things with the field presence tracking on whether or not it's optional. And why that's important is because everybody sees nullable as different depending on the language that they're in. One of is also interesting because it means that I only want one of those things in this message. I'm not going to have multiple of those things in the message. So that's a pretty cool feature. There's a couple additional gRPC things. The default messaging size is 4 megs. So you might want to consider that is changeable. So if I want to change that, but even though the limit can be increased, I would say first look at streaming it or splitting the payload instead, so that you can stay within that, because it's going to be page based. gRPC is a layer 7, so that's at the application layer instead of like a layer 3 at the networking layer. But what that means is that from a load balancing perspective, this might be an interesting conversation for some folks in that I can do client-side load balancing after I discover all my endpoints, right? That means that the client can load balance if I want to scale out, more stuff. It's not just load balancing, in the traditional sense. Reusing channels whenever possible. These are all interesting things. We use the keep alive pings for HTTP2 during periods of inactivity. So there might be some things that you want to do to keep those, connections alive, because the most expensive thing you can do with anything is do what? Create a socket, right? So even when you create a database connection, what's it? A thread and a socket, right? And why is it so expensive? Because you had to start that up. So we want to keep that alive. Reusing channels, max concurrent streams. So max concurrent streams, yeah, there's a limit on how many concurrent stream requests you can have. This is just like, an out-of-the-box limit on how many requests a web server could have. Usually that's dependent on the threads that are going on behind the scenes on a web server. But think about it this way, is that out of the box, it's configured for 100 concurrent streams or connections. So, everything is changeable, but I like to leave it at, whatever the out of the box is until I need to change it. There's some additional information, a bunch of links here. We're going to have Eric D'Andrea on here later. He wrote some great articles. We're going to have him on gRPC and Quarkus. There's some Daniel O did a couple of nice videos on that. And then of course, Camel, Quarkus and gRPC is always fun. And Clement has a really nice article from just a couple of years ago, but it's all still works the same. So that'll all be provided by whoever gets the slides from here.
And we should we'll put a PDF of those slides up on, because those resources are really good stuff. We'll put that up in the repo, I think.
Okay, cool.
All right,
Ian, any comments you want to make about today?
No, I've been quiet because I'm just thinking about rewriting my RESTful stuff.
So Dwayne asked us a question: is this in the Red Hat lab? And I don't know, Dwayne. Yes, you will be able to get a copy of the presentation. We'll put a PDF up in the repo. I'll tweet it, and I guess we'll have a link on the site, on the DevNation site. And I'm not sure which Red Hat lab you're referring to. You can reach me at jeremy.davis@redhat.com, or you can reach me on LinkedIn, linkedin.com/IN Jeremy R. Davis. Or you can tweet at me at Arrogant Programmer, but it's no vowels, ARNG. I can't spell arrogant without vowels. So yeah, if you want to follow up with that, feel free to contact us. I'd love to hear from you. And thank you, everybody. Thanks for staying over too.
Right, cool. Thank you very much.
Cheers,
and we'll see you next time.